So first of all, what will be the flow of the video? Firstly, I will tell you the problem statement. So problem statement. Then we will look the high level approach, that is how the algorithm is working. So this will give you a brief overview and it will force you to think more in depth. So high level. After this, we will also look into the in-depth recursion analysis that we usually do in merge sort by calling the left array the right array. So we will look into that. So recursion analysis. After this, it is very important to analyze what is the time and space complexity for the proposed solution. So we will look time and space complexity separately. And at the end, we will have the Java code implementation for the same. That will alternatively give you a brief understanding and what is the algo and what where to use and what are its disadvantages and advantages. So Java code. So let's directly jump into the process without wasting our time. So what is the problem statement? So you are given an array of n integers and you have to use the merge sort to sort the array in increasing order. So what I am talking about, if we take an example, that will be more clear. So if I take an array 7, 4, 1, 3, 6, 8, 2, 5, 1, 2, 3, 4, 5, 6, 7, 8, 8 elements and indexed with 0 to 7, 1, 2, 3, 4, 5, 6, 7. So what we generally do in merge sort, we partition this array into two halves. So what I'm talking about, we partition this array into 7, 4, 1, 3, 6, 8, 2, 5. That we will look later in the video in the code how we will do this. So now you recall in recursion, we usually preserve the faith that we divide the larger problem into different sub problems and then we find a solution for that sub problem and then recursively call it for the further. So that will end up giving us the desired result. So we will further divide this array into different sub arrays, left and right. So this will divide into 7, 4, 1, 3. This will be 6, 8, 2, 5. So we will do this until we get single elements. So single element, you can say it is sorted. Simple. So this will be 7, 4, 1, 3, 6, 8, 2, 5. So the single element will be considered as sorted. So we have discussed the problem statement and the high level approach, what we will be going to do in the recursion. So let us now discuss the in-depth recursion analysis for the same. So as I told you earlier that we believe that recursively calling the function for different sub problems will give us the result for that problem and we will further use it to combine to form the answer for the bigger problem. So what is our faith here? That we are having an array and we are dividing into left part and the right part. So our faith is that left part will give us the sorted array and right part will give us the sorted array. And we will merge these two sorted arrays to get the final output, which here is 1, 2, 3, 4, 5, 6, 7, 8, the original sorted array we are getting. So let us look how we are doing this. So if I am calling this on the left side, so you can imagine this as a tree. So you can see like we are going into the recursion. So we are going like this, then dividing this further into 7, 4. Then after when we are getting the single element here, that is 7. So single element is considered to be sorted and cannot be divided further. So this will be the base condition for the recursion, that here we will create a new array with a size 1 and we will put this element at the 0th index of the array and we will return. So we will return an array consisting only one element 7 here. Then we will approach further and similarly we will get 4 here. So this is the post order of the 4. So basically this we generally call it as a Euler diagram. So it helps to easily understand what recursion is doing. Then now we getting the left part, the 7 array, and 4 part from the right. Now we will call the merge to sorted array code and merge these array. So what will be the output? 4 7. So this will give at this point. Similarly we will proceed further like this. Here I will get 1 3, and since 1 and 3 is already in the sorted form, so 1 and 3. Now at this point you see we are getting 4 and 7 and 1 and 3, so we end up getting 1 3 4 and 7, the sorted. So you can see how the problem we divided into smaller problem and getting the result by the recursion for a full problem. Similarly, you can see in the right we are dividing into 6 8 2 5. Then proceeding further, here comes the base case and we are getting 6 as a single element in the array and 8. Now in the post order of 8 we will combine this and call the merge to sorted array code, that we will see in the coding part, that will make you more clear understanding. So 6 8. Similarly here I will get 2 5 and we will end up merging it 2 5 6 and 8. So you can see we are getting 1 3 4 7 and 2 5 6 8. This is the left part, this is the right part. So after doing all this, we will at the end again merge this. Like every step we are doing what? We are dividing the array into left part, right part. Then after getting result from separate recursion calls, we are merging it. That is merging two sorted arrays. So after merging this, I will get the output as this, and we will return it in a new array. So this is all about the merge sort, how this is working. So now let us look what will be the time and space complexity, and further when I will code, then it will be very much clear what I am talking about all this.
So let us now see the Java code implementation for the algorithm, and at the end we will also look what is the time and space complexity. So let's start. So firstly I will create a main function that will accept input array. So let me create it, a scanner object, system dot the number of elements we want to have in our array. So int n equals s dot next int. Now an array of size n, array of size n. Now at every I we will have the user input. So this is filling of the array dot length, or you can say simply n I plus plus, or at every index the user input. So now we got our array. Now we will create the merge sort method first. So public static, the return type will be an array that we need to return at the end, the sorted one, merge sort. Now the parameter that it will accept will be the array that we have created below, two variables low and high, as earlier I told you, that will help us partition the array. Now initially what I will do, I will pass the array that we have created, low as 0 as I told you, and high will be the last index of the array, that is array dot length minus 1, and the outcome will be stored in a sample array. You can say the answer, rs, anything you want to do. Now the first step here is to compute mid. So what is mid? Mid is low plus high by 2. Low plus high by 2. Now we will recursively call the merge sort method that will partition it into the left and right. So what I am talking, merge sort array low as it is, that is 0 till mid. 0 to mid is the left part. And similarly in the next step, array, now low is mid plus 1 after the mid, and high is the last index. So this is what we were doing before, and the result will be stored in a separate array. Like this is left side array, left side array, and this is right side array, as we saw earlier in the recursion. Now, what was the third step? We need to merge these two sorted arrays. We got the sorted arrays, that is what our faith was. So what was our third step? The third step was to merge these two sorted arrays which we got. So I will call merge two sorted arrays. So this we have to create now. Merge two sorted arrays, and I will pass the left array and the right array which we want to merge, and the result will be stored in an array answer. So which alternately we will return our answer. So answer. Now let's create the merge two sorted arrays and look what is the code for it. So public static, and the return type here also will be an array. Merge two sorted arrays. The input is the two array that we have passed above, the left side array and the right side array. So what is the code for this? Firstly, we create three variables: int I equals 0, int j equals 0, and k equals 0. So with the help of this I and j, we will keep a counter on the left array and the right array, and with the help of k, we will fill our answer array. So the array at the end which we will get will be of size the length of the array 1 and plus the length of the array 2. So I will create an array with a size of left array plus the size of the right array. Now we will have a condition while we have elements in both of the array, like left side array dot length and the right side array dot length. So until we have elements in both of the array, we will run this loop, and what we will going to do, we will check a condition. If element at left side array, like if I is 0, so you can imagine that the first element at the left side array is less than equals to that of the right side array at j, so we will keep the smaller element. So we are at each step we are making greedy decision that we are keeping the smaller element, so that will alternatively sort our array. So we will keep answer at k as the LSA of I, and we will increment this I and k, since we have occupied I and we have an element in our new array, so we will k plus plus. Else what is the case? Maybe the left maybe the right side array element is smaller, so we will keep that. So answer at k will be RSA of k, and similarly k plus plus, and we will increment j here. Now so this loop will do all this. Now there may be a condition that any of the array is completely iterated here, so we will break the loop since we have a AND condition, so both here should be true. So if any of the condition will false, we will break, and we will copy the remaining elements present in that array. So while I is less than LSA dot length, since like we have elements present in our left side array, so we will keep those elements LSA I, and again k plus plus I plus plus. Similarly, if elements were present in the right side array, so similar code k RSA at j, k plus plus and j plus plus. So that is all about the merge to sorted array. At the end we will return this array that we have filled. So here we got our sorted array, and after this, when we got our result in this answer, we will return this answer from here, the merge sort method, return answer. So that is all about merge to sorted arrays and merge sort. So there is a fault in this code. We are missing the base condition. So what I'm talking about, like we are partitioning the array at left and right. So there will be a point when we have only one element that we saw that is considered to be sorted. So what is the base condition? If low is double equals to high, that is only we have one element in the array. So we will create a new array, let's say temp of size 1, and at the 0 index of this array we will store the element at that point, array of low, and we will return this temp here. So otherwise our code will give a infinite loop. So this will be the base condition. So now if I give it a run, so let's run our code. So let's say we have 5 elements in our array, so n equals 5, and the array elements are 4, 9, 5, 2, 6. So anything you want to enter. Now if I press enter, so you can see we are getting the sorted array 2, 4, 5, 6 and 9. That is all merge sort is doing. So let's now see what is the time and space complexity. So the time complexity for the merge sort will be O(n) log n. So this is the time complexity O of n log n. And if I talk about the space complexity, so that will be O(n). Since we are using an extra space in the merge to sorted array code, where we are declaring a new array in which we are getting our answer. So O of n.